Hey class, so today what we're going to do is we're going to go to chapter 3.4, quadratic and power models. Now you can solve a lot of these by hand, and typically during a regularly scheduled semester when we have a whole lot of time to go through this, that's typically what I'll do is go through it by hand first and then show you how to do it on the calculator. But because we're in such a condensed summer semester, and we usually wind up with the calculator method anyway, I'm going to show you how to do this on the calculator. It's really easy. So we want a parabola that passes through the points 0, 5, 4, 13, and negative 2, 25. And it says write the equation of that quadratic function. So the easiest way to do this, and I'm going to show you the easiest route to get there, is to just do it on the calculator. Now to do that, let's go over to the TI real quick. It's important to note that you're going to need these points right here. And obviously the first one's a X, the second one's a Y, X, Y, X, Y. And you need to keep them in order. And I'll show you exactly how that works. So let's go to the calculator real quick. Alright, so now that we're on the TI, like I said, the important thing is to keep your points together. So to start it out, we're going to go stat edit and go to our list here. So our first point was 0, 5. So the 0 is going to go on L1, the 5 and L2. The next point was 4, 13. And the next point was negative 2, 25. It's important to keep them in order. That's the most important thing. Okay. If you put them out of order, it's not really going to work. So what we're going to do next is we're going to we want to find, it said to find the quadratic function for it. So what we're going to do is we're going to go stat, calc, and we're going to do quadreg. So we've done linear regression already, but now we're going to do quadreg. Now our X list is L1, our Y list is L2. Like I said, you have to have the corresponding values side by side in that or else it won't work. If we want to, we can store it in the Y1 if we want to. And after we do that, we're going to hit the calculate button. And what it does is it calculates this for us. It says, okay, here's your equation. Y equals ax squared plus bx plus c, where your a is 2, your b is negative 6, and your c is 5. So it gives you your equation. And if you come over here to your y where you stored it, it might have it rounded approximately, which looks like what it did. So that 2, it wrote it as a 1.999 and a 5 as that. But it's really just the closest number that is 2. So a lot of times it's easier to follow it just directly from the regression setup here after you do it. If you can get there, stat, calc, quadreg, and calculate it, and here's your answer. So like I said, what we'll do is I'll go back over to the page, we'll write it down, and we'll be done with it. That's the way that I suggest doing it. It's the easiest way to do it. If you want to do it by hand and do a bunch of cancellations and substitutions and take that elimination method and kind of work with it, you can do that as well. But this is honestly the easiest way to do it. Alright, so like I said, right back here, if we write it out, it looks like y equals 2x squared minus 6x plus 5. And it's that easy. Now, if you'd like to, you could try to work it out by hand with that elimination and substitution method, if you know how to do that, and practice that if you'd like to. I don't care to see that work. I just care that you get the right answer, and the calculator gets you there so quick. So if we scroll down to page 2, it gives you another equation, or another set of points. It says find the equation with the quadratic function whose graph is a parabola containing the points negative 1, 9, 2, 6, and 3, 13. So let's go over to the calculator and type those in. Alright, so we're back over here at the calculator. We're back in our list. Remember to get to the list, stat edit. I've already typed all the points in. The first point was negative 1, 9. Next point was 2, 6. And the next point was 3, 13. You have to have them in the correct order. Like I said, you have to have the corresponding numbers with each of them. X first, Y second. Okay, so now we're going to go stat, calc, and we're going to scroll down to quadreg. Hit enter. You can store it if you want to. I'm not even going to store it here because we don't really care about the graph in this part. And we just calculate it. And it says your answer here is y equals 2x squared plus or minus 3x plus 4. And it's as simple as that, guys. It really is. So let's go to the paper, write it down, and get back with it. Alright, so like I said, just write it down. Y equals 2x squared minus 3x plus 4. And it's that simple. So what'll happen after this, like I said, you can solve those by hand, and there's methods and stuff to doing that, but you've got access to that calculator. That's the easiest way to do it, and I'm trying to show you the easiest way to get to what you're looking for. Now, this one here, it gives you more of a word problem layout for your question. So let's look at it. It says table 3.9 shows the dollar value or projected dollar value of the U.S. mobile internet advertising market for the years 2006 to 2012. Okay, and you've got this, obviously, this list here. First thing it says create a scatter plot of the data with x equal to the number of years after 2000. Since that's the case, what you're going to have here is this is going to be year 6, 7, 8, 9, and I know my 8s aren't ever pretty looking. This will be year 10, 11, and 12. So that's the only really adjustment you have to make there. Once we do that, okay, what we're going to do is essentially we're going to graph the scatter plot, which means we're going to put it in our list and graph it. We're going to find the quadratic function that's the best fit for the data, and then we're going to look at them both on the same axis, and then we'll use that model to find the year in which the mobile internet advertising market is projected to reach 3 billion. So that's kind of the process we're going to do once we get to the calculator. So let's go over to the calculator really quick and do that. What we'll do is we'll find it on the calculator, we'll come back, put it on our paper. Alright, so I'm over here at my calculator. I already have a list typed in. Make sure that, like you said, we adjust it for years after 2000 so that you do right 6 through 12 just like I did here. If you need to take a minute and pause and get all your numbers typed in, please go ahead and do that so you can follow along with me. Now what I'm going to do is I'm going to hit Stat, Calc, and I'm going to do the quadreg again. Okay, and I'm going to store it in my Y1 so we can see it with our list. Okay, so I'm going to come over here, store it in Y1, calculate it out, and here's your equation. So it's got your A values here, your B values, and your C values respectively that go in your equation. We'll go back to the paper and write that here in a little bit. Now, what I'm going to do is I'm going to hit zoom, and I'm going to do zoom stat. And when I do that, you can see the points, and you can see how well the line fits the points. It does a pretty good job. It goes through several of them, and it gets really close to the other ones. So that's a really, really good line of fit right here. If your stat plot's not popping up and looking like this, make sure if you go second stat plot that your first plot is actually on, and if you select it, it looks like this with the scatter plot selected. If it's off, it might just show you the line. So make sure you have it turned on. But that's what it looks like. Now, part D said use the model to find the year in which the mobile internet advertising market is projected to reach 3 billion. Okay, so our X is our year, our Y would be our billion part, and we got to make sure if we look over here, the advertising percent or market percent is in billions of dollars, so we're really just looking for 3. Okay, so if we can go second table sometimes, and we can scroll over here until we find 3, and you know it's around year 18. If you want to be more exact, you can try to be more exact with that. The way to do that would be go Y equals, and let Y2 equal 3. Okay, when you graph that, if it doesn't show up, probably means you need to zoom out, which is what we will do. Okay, so we'll zoom out. And you can see this is our Y equals 3 line. So wherever this hits is going to be our approximation. To find it, we can go second calc, intersect. Okay, and what we'll do is make sure you have the initial line selected, make sure you have your new line selected, and then just guess where they intersect at. So this tells us that it'll reach 3 million in year 17.839631, so approximately year 18. So let's go back to the paper and put all this down that we've learned on paper. Alright, so we've got the equation here that we found. So I just estimated it to 3 decimal places for all of them. So y equals 0.015x squared minus 0.105x plus 0.137. Okay, we already graphed it. We've done that. Does it seem like a reasonable fit? Yes, it does. Okay, use the model to predict the year. We did that. We found it to be year 18. Okay, but year 18 isn't going to be the answer they're looking for. We're looking at years since 2000, so it'll actually be year 2018. That would be the answer that we'd be looking for this one, because you got to readjust for that. Now, if we move on to the next page, The next page says North American cloud computing revenues from 2008 and projected 2020 are shown in the table. Create the scatter plot. And then we're going to find the best fitting quadratic model for the data. Okay. C says graph the aligned data on the same axis. Does it seem reasonable? D says use the model to predict the revenue in 2019. Is this estimate close to the data projection? And E says, in what year does the model predict the revenue will be 65.98 billion euros? So let's go about doing this. Okay, first thing, we got to get this list typed into our calculator. So if you need to pause, go ahead and do that, because I'm going to go ahead and have it typed by the time we get over here to the calculator. Alright, so we're over here at the calculator, hopefully. The one thing that I didn't tell you to do that I hope you picked up, otherwise you're going to have to go back and redo it a little bit, make sure you adjust your years accordingly. In the problem it said that it was talking about years after 2000. So your first year here was 2008, so we start with 8, and then we count down, and we'll make sure you have the corresponding number next to it as well. Take your time typing these numbers in, because if you type one wrong, you're going to be off, and it's going to really make a difference. First thing we're going to do, we're going to go Stat, Calc. We're going to figure out what the equation of this line is. So we're going to quadrig, and then we're going to store it, and we're also going to see how well of a fit it is compared to our scatter plot. So we calculate it all out. We get the equation of the line, which you can go ahead and write down if you want to, but I'll write it down later too, so you can compare it when we go back to our page. So the next thing we're going to do, we're going to go zoom. We'll go over here to y equals. We don't need this y2 equals 3 anymore. I'm going to go ahead and delete it out. But this first line, or first equation, is the line that we just did because that's where we stored it. We're going to do zoom stat. And you see that it does a very, very good job of estimating these points. Okay. Now, the next thing that it had asked, after you did that part, it asked you to, is the model a reasonable fit? Yes, it is. And we want to use the model to predict the revenue in 2019. Okay, so 2019 would be year 19. So all we have to do for this is second calc value for year 19, hit enter. Okay, and it tells us that it's 51.96633. Now our original value for that year, if you recall, for 2019 was 51.785, which is pretty freaking close. So I mean, it does a really good job of estimating here. Okay, so that would answer, I believe, part D. And then part E says, in what year does the model predict the revenue to be 65.98 billion euros? Okay, so 65.98. Now sometimes you can hit second table. 65.98 actually shows up directly here on year 21. Okay, that's the easy way to do it. That's a lot of times what I'll do. If you don't feel like you can find it in the table, the one they're looking for, doesn't mean you're wrong or you did something wrong. Sometimes you just have to come over here. Like I said, we already know the year's 21, but sometimes you have to come over here, 65.98, put it in your Y2, just like we did before, graph it, figure out where they intersect at, just like we've done before. And it'll tell you the same thing. It's approximately 21. Okay. So, see, approximately 21. We would definitely round that up. So, there you go. It's that simple. Calculator does a lot of work for you. You just got to know how to manipulate it and use it. So, let's go back and write everything down on the page. Alright, so we're back over here. Just going through everything. The best fitting quadratic model for the data, I just took and actually wrote the equation down. I rounded to 3 decimal places, so we got y equals 0.231x squared minus 2.246x plus 11.131. So that's your best fit equation of the line. Does the model seem to be a reasonable fit to the data? Yes, it was. Okay. Use the model to predict the revenue in 2019. Is the estimate close to the data prediction? So this is what it predicted. And yes, it was close. Okay. In what year does the model predict the revenue will be 65.98 billion euros? Year 21. But really the answer they're going to really want you to use is 2021. Okay. This is the answer I'd be looking for here. Alright. On to the next one. So if we start comparing linear and quadratic models, for linear models we use first differences, for quadratic we use second differences. So what we're going to do on this one is we're going to find the first and the second differences, okay? So if you look at the difference between 68.6 and 117.6, what you're looking at, you can take your calculator to do it. So let's see if I can roll mine up and do it as well. So we've got 68.6 minus 117.6 should give you 49. So your difference here is 49. So let's get that written down. Okay, now if you look at your difference between 117.6 and 147, so 117.6 minus 147 should give you negative 29.4. Okay, so the difference here and this one should actually be negative as well. So, alright, now if we look at the difference between 147 and 156.8, hopefully you're doing it over here on your calculator as well, we get negative 9.8. Okay. Now here we get a positive 9.8, we get a positive 29.4, and we get a positive 49. So all I'm really doing for this first difference, like the very first one I did 68.6 minus 117.6, and then the next one I did 117.6 minus 147. Now if we're going to look at second differences, what we have to do here, flip a different color marker to contrast. Now we look at the difference between negative 49 and negative 29.4. So if I do basically negative 49 minus a negative 29.4, so plus 29.4, what you wind up with is negative 19.6. If you look at the difference between negative 29.4 and negative 9.8, so 29.4 plus a 9.8 should give you a difference of, same thing, negative 19.6. And the difference here is actually going to be a negative 19.6. Difference here is going to be a negative 19.6. The difference here is going to be a negative 19.6. And we know from first differences here, the ones in purple, if your first differences are exactly the same, then it's a linear equation. Well, if your second differences are exactly the same, it's going to wind up being a quadratic equation. So first difference is the same. That equals linear. Oops. Linear. Sorry for the terrible, terrible handwriting. Let's erase that and make it look at least a little more decent. Okay. Second difference is equal or the same. That's when you get a quadratic equation. Alright. Now it says now graph the scatter plot and estimate the quadratic equation. Now we've done enough of these that you should be able to do this on your own now. So what you're going to do in your X list is you're going to type 1 through 7, and then you're going to type the height that corresponds to it, graph the scatter plot, and then estimate the quadratic equation. What you're going to find when you do that, if you take the time to do that, and you should, is that that line fits these points exactly. If you graph it and compare it, you'll notice the line goes exactly through all these points. Okay, so take a minute and do that. Now, we really only have 2 pages left. I'm going to do page 6 and I'm going to leave page 7 up to you. Okay, so on page 6 it says figure 3.42 and table 3.13 show that the percent of U.S. adult population with diabetes, diagnosed and undiagnosed, is projected to grow rapidly in the future. It says find the power model that fits the data with X equal to the number of years after 2000. Use the model to predict the percent of U.S. adults with diabetes in 2015. In what year does the model predict the percent to be 29.6? Okay. Alright, so what we're going to do here is power model is different from the quadratic model, is different from the linear model. Okay, power model is just the next step up, and it works in the very same way. It's just the same setup, different button that does basically the same thing. So I'm going to take this over to your calculator. I'm going to get the list typed in right here, and once I get that list typed in, we'll go about finding this power model and answering part B and C. Alright, so I've got it typed in my list in my calculator here. So make sure it says year since 2000, so we do have to adjust our X list here, starting with 10 going to 50. And then you type the corresponding values here. Now what we're going to want to do here, I'm going to hit Stat Calc. We're not looking at linear regression or quad regression anymore. We need to scroll on down a little bit and find our power reg. Okay, so we're going to select power reg, and it's set up the same way. I'm going to store it in my Y1. Okay, and I'm going to hit the calculate button. Alright, so what a power reg does is it looks like y equals a times x raised to a power of b. So it's a really simple equation. And what we have here is y equals 4.95 approximately x raised to the 0.5 if you round to 2 decimal places. So if we come over here, we hit the zoom button and we do zoom stat, we can see the points and we can see the estimation with the power model, which is what we want. Alright, if we go to answer the next set of questions, it says what will the model or use model predict the percent of U.S. adults with diabetes in 2015. All we have to do for that is we go second calc, value 15, hit enter, and it finds it for us. Okay, easy enough. 18.926, right? So, and if you look at the one that's it's compared to, we know in 2015 it was 18.9. So it does an excellent job of estimating that particular year with this curve. Alright, the next question said, what year does the model predict the percent to be 29.6? Now, two methods of doing this. You can go second table and you try to find, oops, let me go ahead and clear out this Y2. That was from the previous problem. If we go back to the table now, 29.6, you can scroll down till you find it if you want to do that. It's really not that hard to scroll that far. You wind up with 37. If you don't want to, come over here to your Y2, do 29.6, hit enter, graph it, wherever your lines intersect, that's going to be your year, so you can do second calc, intersect, okay, this line, that line, and they intersect somewhere right around in here. It'll tell you the same thing, approximately year 37. So it's really that simple. Your calculator does all the work for you. You just got to know how to use it. So let's go back to the paper, write this all down, and discuss the very next page. Alright, so back up this problem here. Our equation was y equals 4.95 times x raised to the 0.5. We used the model to predict the percent of U.S. adults with diabetes in 2015, so it's 18.93. If you want to write the percent on that, that'd probably be a good idea as well. So that's actually a percent, so you can put a percent sign here. It says in what year does this model predict the percent to be 29.6? It's year 37, but like we've been doing with everything else, it's years after 2000, so it'll actually be 2037. Okay, easy enough. Now if you move on to the next one, I'm going to let you do most of the next one by yourself, because you should really have the hang of it. It's not that hard by now. But with the next one, you have a big table, so it's going to take you a while to type it in, take your time typing it in, get it all right. If you can handle this one, you should really know what you're doing. The question says find a quadratic function that models the data years after 1960, which is important. So you need to adjust your years from 1960, which means your first year here, 1968, would be year 8. This would be year 9, this would be year 10, 11, so on and so forth. Okay. You're going to find the quadratic equation in the first one, the power function in the second one. Okay. You're going to graph both models with the data and discuss which is the better fit. So when you look at your scatter plot on your TI, you should be able to say, hey, it looks like one of these fits really well and one of them really doesn't fit at all. Okay, it might not be the one you expect. Okay, then you're going to wind up using the power model to predict the purchasing power of the dollar in 2055, and then when you're going to find the purchasing power when it's 0.40, so 40 cents. See if you could do that. If you have any problems doing that, let me know. But you know how to do the quadratic function, so quadreg. You know how to do the power function, powerreg. You know how to store each of them. The only difference is you're going to store this one in Y1, and then store this one in Y2. So same method, except when you select where to store it, don't select Y1, select Y2 for the second part. Then you'll be able to see everything on your graph. And let me know how that goes. If you have any trouble with that, let me know. Hopefully this was a pretty easy chapter for you. The computer pretty much does it all. You just got to know how it works. So any problems, let me know. Shoot me an email. And make sure you get ready to take your quiz today as well. Thanks for watching.